We are going to be talking about eBays tonight, what goes into them, and how to, how they actually separate your sections and what electronics actually make that happen.
Modifying delay grains, which are parts of motors, are kind of built into the motor. And it increases the time before the built-in black powder ejection charge at the end of a motor ignites and essentially breaks apart the rocket and deploys the drogue parachute, or the parachute that is at the apogee, or the highest point of the rocket's flight. So that's kind of the application of the delay grain. And you can reduce the time before this delay grain that's built into the motor ignites by using a drill bit fixture, taking off the ejection cap on the top of the motor. He's inserting the drill bit into that cap, and then he is physically just twisting the drill bit and removing enough of the delay grain so that, say, if the motor started out with 14-second delay grain, you can decrease that by a specific number of seconds, whatever makes sense for your rocket flight. And then after you drill out that material, you just replace that ejection cap into the top of the motor, and then insert the motor into the metal reloadable casing. So you can only do this, though, in certain sized motors. So the larger sized motors, like motors greater than 54 millimeters in diameter, they just don't have these delay grains. And then the motors that are smaller than 29 millimeters in diameter, they have ejection charges, but you can't modify the delay grain on them. So this is just kind of like an interesting trait of motors that will be relevant for the rockets we built in the spring.
eBays. eBays are important because they control parachute events. We've been talking about parachutes a lot. And so like Tom was talking about, the delay grain is one way to get your parachute out, but sometimes you need to get more than one parachute out and you only have one motor. So you can't just use the delay grain. And that's where electronics bays comes in, because they allow you to use flight controllers like the little red board pictured there to blow out black powder charges and eject your parachutes. And the black powder charges are the same substance that's in the delay grain of the motor. It's just that you're putting it in a little blast cap. That's that little white tube on the end in the bottom picture. Yeah, perfect. Thank you. Those are called blast caps. Put the black powder in there. And so you're just putting it in instead of it coming with the motor. So things that need to go in eBay: you need your flight controllers, you need batteries, you need a thing to hold your batteries, you need to wire everything together. And you need to be able to turn off the boards from the outside of the rocket. Because your boards are controlling pyrotechnic events, they're wired to black powder, which is like a little explosion waiting to happen. You can't have them armed until the rocket is on the launch rail ready to launch. Because if the charges go off when you're not on the launch rail, it can blow the rocket apart. It can be next to somebody when it does that, and you don't want to be standing next to it too close when it goes off. So that's an important safety thing, and that's what that key in the middle there is. It is a key switch, so you can just turn the key, and that will create continuity and arm the board. All the commercial flight control boards have a couple of switch inputs to turn them on and off. So that's an important safety thing. Challenges of eBays are getting everything to fit. It's always harder than it seems like it should be, because in addition to having everything fit on the little rectangular board, you have to then fit it in the tube as well. So you can't have things sticking up into the corners because it has to go into a tube at the end. You got to wire everything together. You got to wire everything so your wires don't get crossed and short each other, and make sure there's no funky business there, because you need everything to be good and solid. Otherwise, you're going to have parachute issues. And as I believe we may have mentioned a couple of times, parachute issues make you sad. A couple of best practices when you're doing eBays: after you have it all put together, you want to check for continuity and make sure you wired everything right. That will save you a lot of sadness when you're trying to get everything squared away, and you have to test parachute ejection on the ground before you send it up. And it's just easier to make sure you have it wired right before you try and do anything with it. The other important safety thing about eBays and for parachute ejection in general is that you want to have redundancy in your deployment event controls. So you never want to have a single point of failure for deploying a parachute. That means that you want to have two boards controlling each deployment. You'll have one board sending the signal, and then you have a second board wired up to a charge in the same bay to do a backup one. So if something happens with the main board, if something happens with the first board's battery, your parachutes will still come out because you have a backup system. And so when we talk about redundancy in flight events, that's what we're talking about.
Yes, so the point of the eBay is to blow your rocket up so parachute can come out. Also, it looks cool, and it will tell you if it works. So what you need is you need an altimeter, because you need to know how high the rocket is, so you can know when to burst. And you also need a lot of black powder, and you need things to hold that black powder that ideally won't explode when your black powder explodes. So to accomplish this, a big thing is shear pins, which we've talked about before, but they're basically screws that are meant to break. So you have your rocket tube like this and your coupler. You put the shear pin through the coupler and the rocket tube on both sides to hold it together. And then when your black powder blows, hopefully it blows the shear pins right out, and that's where you get that nice break in your rocket. So there's a fancy dancy Excel sheet that we use to do this. I'm more of a fan of the iterative approach, because you can see here is basically just blowing things up until you get to the point where you get as much blow up as you need. And we always do ejection tests before launch. So there's some fun videos of these. I believe I made a hype video for this club that features one on a bale of hay. It go boom to make sure the boom happens, and it just separates. Usually you don't want to do this on a bale of hay because it's flammable, but you do what you can. And then again, you can either do it the smart way or the empirical way, but mechanical deployment is what we're going to do, like our club is going to do going forward, but this is the more fun stuff.
Some components, Becky kind of already mentioned a lot of this, but I'll just point to the pictures. This thing up here in the corner is it's a 9-volt battery holder, because obviously you don't want to just toss your batteries in there and let them float around, because for one thing, they might come disconnected from the wires that you have connected to them, and there's some pretty serious accelerations during the flight. So depending on what your rocket's made out of, the battery might punch through the tube or damage other components in the eBay. So it's important to hold everything down properly. And terminal blocks. So the terminal blocks are a component of the flight control board usually. So in this picture here, these blue guys right here are the terminal blocks, and they're places where you can attach a wire. So you can loosen these screws up on top here, and then slip wires in, and then tighten the screws down on top of the wires, and it'll hold them in place. So two of these screws, you've got labels here, but two of these screw terminals are for the battery wires, the positive and negative leads from the battery, and two of them are for a switch. So you essentially just short out the switch terminals to tell the board that it can turn on safely. So that's what you do. That's what you accomplish with the key switch on this one, or you could use a different kind of switch, like a rocker switch like this. And there are other kinds of switches you can use too. And let me think. Oh, and then the other two sets of screws on this thing are for the main and drogue parachute charges. So you can wire up your E-match to those things. So the E-match is the thing that that sets the charge off. This board right here is called a stratologger. And you can program it with Perfect Flight software, I believe is the what it's called. You can tell it when you want the main charge to go off. The drogue charge automatically goes off at apogee because that's generally when you want the drogue to deploy. If you want to know actually how these boards work, not too long ago I posted a schematic for, I don't know if you guys can see me, but for these Easy Minis, everything on them in the general chat, intro airframe general. Yeah, here's an Easy Mini, and you can see these are the screw terminals. Right now, the switch terminals are shorted with just with this wire, so it'll turn on if I plug it in. You can hear it beeping. Maybe you can. I don't know. Some other things you might want to use: heat shrink tubing. Heat shrink tubing is essentially just a more permanent alternative to electrical tape. So if you connect two wires together, say solder them together or wrap them together or something like that, or you crimp a wire inside some kind of connector or something like that, and you want to sort of seal up that connection so that you don't have exposed metal that could cause problems if something else touches it. You can use heat shrink tubing. It's these little tubes like this. It's squishy, and you cut the length you want, and then you pass it around the wire, and then after you've made your solder joint or whatever, then you slide it around the solder joint, and then you take a lighter or a match or a heat gun to it and heat it up, and then it'll shrink around that connection and provide it with a little bit of extra strength, but also just insulate it. That's the primary purpose. Then an E-match, that is, wait a sec. Do we have a picture of an E-match on here? What is this thing here?
I think that's one.
Yeah, that's one.
Yeah. Okay. So yeah, we got an E-match here. The purpose of the E-match is to create a little spark and light the black powder, so the black powder explodes in the blast caps. And when the black powder explodes, it converts this small volume of solid to many moles of gas, right? So you end up with high pressure inside your tube, and it breaks the shear pins, and your parachute comes out. Then we've got a 9-volt battery here. That's a common battery that we use for these small circuit boards that don't really do much besides blow charges. You can also use small lithium polymer batteries for the same purpose often. That's this guy down here. It's called a LiPo. Here it is. So LiPos have much higher energy density than just about anything else. So they're good. They're lightweight, more so than 9 volts. A single LiPo cell is 3.7 volts. So depending on what your application is, that might not be enough though. So in which case you'd need multiple cells. So this is a 3-cell LiPo. And a 9-volt battery is actually a 6-cell alkaline battery. So if you ripped open the inside of this thing, there'd be 6 little things that look kind of like AAAs, and they're all wired together inside here. And then connectors. You need connectors to hold everything together, because obviously you could just solder it all together permanently. But then it would be hard to fix things if you got something wrong or if something broke. It would be hard to isolate the problem. So it's good to use connectors. So here we've got a 9-volt clip connector So those are, you've probably seen those plenty for connecting to the 9-volt batteries. In the case of this Easy Mini here, this is a JST PH 2-pin connector. So there are a bazillion different kinds of JST connectors. They're pretty common on batteries, and there are lots of other types of connectors too. And then, you know, if you're doing other crazy stuff or running other systems besides just black powder charges, you might have other boards inside the eBay to control those. Just, you know, so you're aware, they do exist depending on what you're doing.
And so you've gotten to see all the little components of what your boards might look like, but now you have to figure out how you're going to fit them in a nice, neat package. There's no real set design for how things have to be, but we've noticed that there's kind of a recurring theme of what works. So we tend to be using a lot of the sled designs that you'll see here on the right. It's basically 2 sheets of parallel wood that we cut out with a laser cutter, and you just lay your boards down and make sure that everything fits nice. They're basically like these, we call them sleds. They're removable, they're in slots, and then you can see that they sort of fit in these slots on the circular bulkheads on either end. And actually, if you, in this particular set, you can see another example of a blast cap up at the very top end of that bulkhead, those 2 protruding circular bits. Those are where you would store your gunpowder or your black powder, and that's where it goes kaboom. And like I said, there's not really a huge standard, and if you want to flip the slide, there's a couple other examples. On the left is one of the old comp rocketry eBays. And so this one is just holding a single stratologger, I think. So they basically just 3D printed the entirety of their eBay, and they made a nice little slit for it, and it slips right into the tubing, as you can see in the bottom section there. And then they have their continuity switch towards the far right end of it. And then one of our more recent eBays, which is just hectic with wires, is on the far right over here, which had, I think this was the one that was launched. This was our last launch before COVID, actually. This was the one back in February. And we were testing, what was it, 2 dual deploy systems, or was it a single dual deploy system? Like,
A dual deploy system and a parachute, or sorry, a payload retention system.
Okay.
So the bulkhead closest to us is dual deploy, and the other bulkhead is payload retention.
So yeah,
it's
this
redundant.
this is like an example of it, a really pretty advanced eBay, and it's kind of probably the most ambitious one that we've done. Basically, this is an example of how big they can get, but ours are not going to be that crazy. They're probably going to look more akin to the one on the left here. We're going to have a couple like redundant systems probably, so it'll be more than just a single strat. But this is what they can be. And if you're interested at all in electronics, there's a lot of opportunity to learn for this. So don't feel like you're stuck in Airframe 2. There's plenty of people we can connect you with if you're interested at all in that kind of stuff. So that's 2 sleds. But in this, we have another example here. I've shown you guys this before. This is the CAD of the test rocket that Redshift is currently working on. And because it's even larger by diameter of tubing, they had space for basically a 3-sled system. So you can see here that we have all 3 of these sleds that kind of form a triangle right around. And then that way you get to fit even more stuff. And if you do a cutaway on this guy, you can actually see the battery out on the end. So I don't know if this is the best example. Yeah, you can start to see the batteries building up. So they sort of stored the batteries in shelters on the inside, kept the boards out on the outside. But it's basically all just a matter of space management. So
This
whatever
is the 6-inch, right?
I believe so.
This is 5.5 inches
Okay.
Okay.
because we weren't thinking straight. We should have done 6 inches.
Yeah, that's about it.